All right, welcome to part one of your EMF education series, where I'll walk you through the four types of EMFs, what are the sources, common sources, how it's measured, and how we mitigate against them. So electromagnetic frequencies are, you can't see them, you can't sense them, you can't smell them, you can't hear them, you can't feel them, but they definitely have an impact at the cellular level. They can lead to oxidative damage, cellular damage, mitochondrial dysfunction, a lot of neurological symptoms, even things like tumors and cancers, headaches, fatigue, brain fog, blood pressure, mineral imbalance, hormonal imbalance. So having downstream effects, right? So once your mitochondria is not functioning optimally due to the interference from electrical and wireless radiation, magnetic radiation, it leads to a whole host of energetic symptoms within your body. And this has been established by thousands and thousands of peer-reviewed studies, and also acknowledged by the World Health Organization as well. So let's get into it. The first is what we call the electric fields. So we're gonna go over that first. Electric fields comes from any of your appliances plugged into the electrical grid. So once you plug, let's say, a fan into the outlet, or let's say a light bulb into an outlet, you're essentially pulling AC, or alternating current electricity, from the outlet to the appliance. So right now, let's say if I measure the electric fields at the outlet, it will be very high. Once I move further away, it's going to be very low. You kind of want that number around where we have it now, especially if you're close to it, around 1 or less than 3 maybe, but ideally less than 1 or 1.5. Now, what happens once you plug an appliance into the outlet is that the source of electric fields is not just coming from the outlet, but it's also coming from the device you're plugging it into, even if that device isn't powered on. So this is a very safe looking low power lamp. Let's see what happens when I plug it in to the outlet. Wow, so a sudden spike from 1 volts per meter to almost 400 volts per meter. Right. So imagine like sleeping next to this or working next to this, which is the intent of a lamp, right? You want to use the light illuminating the area around it. So you're likely going to be in its proximity. What can we do, right? So first, of course, distance always helps. Moving away from the source, known as the inverse square law. For every, let's say, X amount of distance, you're reducing your exposure by 1 divided by that amount of length, to the power of 2. So that's the inverse square law. So I can illustrate that. Right. So distance helps, but sometimes you can't avoid being close to those. And even at 15, you're still getting some level of exposure. And imagine staying like that all night long or all day long in your office can definitely lead to some symptoms. So let's talk about some strategies. Apart from distance, electric fields can be mitigated using a ground. So what I mean by ground is usually it comes as a third prong of your outlet or your appliance plug. That will be the ground where it basically pulls the remaining electric fields to the ground of the house, right? So I can illustrate that, and this is what we do during our EMF assessments for clients. We use a meter to measure before and after. Before we do implement strategies like grounding, we also make sure the outlets are properly grounded, because if they're not grounded, even if we use a 3-prong grounded outlet or plug, it's still not going to ground your device, and it's likely not to make a difference on the meter itself. So we have an outlet tester, and And this is exactly what we want to see, which is the first two LEDs lighting up. The third one is not lighting up, which means this outlet is properly grounded. So in our assessments, we plug this into virtually every outlet of your home to make sure it's properly grounded. Once we ensure that, a couple of fixes. One, we can find a USB adapter with a ground prong on it. That would highly eliminate the electric fields from this device. So let's say you were shopping for a television or refrigerator. If you were able to find the models that come with the ground prong, that would drastically help with electric fields. But let's say you already have that device, or the ground prong, it just isn't available. For instance, USB chargers, it's very hard to come by ones with a grounding prong on it. So I have this hack. This is basically a grounding USB adapter. What it does is it pulls whatever device it's plugged into, it will act as the grounding for that device. So it pulls AC electric fields to the grounding prong, into the outlet, and down to the ground of your house. And note that these two aren't conducting any electricity. So these two prongs are just pseudo prongs that are just there to, keep the plug snug in the outlet. So don't worry about damaging your appliance by plugging this adapter in. So let's see what happens. Now we're getting really high. I plug this into another outlet. It could be any outlet. So I'm plugging in the ground. Levels are still high. Let me plug in the USB into the outlet, or into the charger. Now once the USB cord is grounded, it essentially grounds the USB charger, which essentially grounds whatever's plugged into it. Now we're back to that really nice level, and your nervous system is no longer picking up on that huge amount of electric fields without the ground. Right. So this is really helpful and very inexpensive. Something you can do for many different types of devices. I do this for my gaming consoles, for my TVs that come with two prongs, essentially any appliance really. And another thing to note, so I'll show you this in a second. So this is another example. A lot of appliances that come from the EU and have this EU plug, it's going to look round, and it's going to have this grounding sort of metal piece that ideally, if you're in the EU, there's going to be a grounding prong in the outlet itself rather than in the plug. So once you plug this in the EU, it's going to ground whatever device, because it's prepared, right? You can see this grounding symbol. But when you're in Thailand, you understand that you can just plug this right into the outlet, but you're actually missing the ground because outlets in Thailand do not have the grounding built into the outlet. It has to be built into the plug. So I'll illustrate this real quick. This is actually my sauna. It's a low EMF sauna, and you can see electric fields. Let me just turn that on. Let's put this down there. Right. So currently it's very low because it's not plugged in. Now I'm gonna plug it in without the grounding adapter and see what happens. Again, levels are crazy high. And I haven't even turned this on, right? Right. So it doesn't matter if your appliance is on or off, really. Off usually means a bit lower, but as long as it's plugged in and ungrounded, you're gonna get that exposure all day long when you're around it. So solution here, similar to what we did with the USB grounding. In this case, it's a little easier because the sauna doesn't come with a USB port, obviously. And if it did, you might be able to plug a USB grounding adapter into the outlet and measure electric fields. But in this case, the solution is even easier. So what you can do is find a grounding adapter for the EU plug, which basically fits right in like that. Some versions come with just this prong and you can just push it in. Works the same way, but this is a bit more durable, I would say. And let's retest with this grounding adapter in. Here. So you barely hear anything, even though it's plugged in. We're still at that very low level of EMFs. Of course, when you're in a sauna, you want to have a relaxing experience, activating the vagus nerve and not getting your sympathetic drive. You want to be in parasympathetic when you're relaxing, when you're trying to get healthy. But are you getting a trade-off if your sauna is really high in EMFs because it's not properly grounded? So now, once it's grounded, even if you have the lights on, we're still at a very healthy level of electric fields. So that's part one. Electric fields is not the only type of EMFs. In the following series, I'm going to cover magnetic fields, which can also be measured by this meter. I'm also going to touch on radio frequency or wireless radiation, which is something a lot of people already know about, but I'll cover it a bit more in depth. And lastly, dirty electricity, all of which have biological impacts on your body. So thanks for watching. So one of the things I forgot to mention in the electric fields training series is that there's some really good shielding materials for electric fields as well. So aside from grounding, the appliance, using distance, using a grounding adapter, you can also use some shielding materials. This is the fabric we really like to use. You know, it's really high quality. You can turn it into curtains. You can also essentially make any material out of it. So curtains are good, clothing, even, you know, a canopy over your bed. So you have a sleep sanctuary where electric fields are not invading into your sleeping area and putting stress on the body whole night long. But let me just demo it real quick on how effective it is for electric fields. So I have the same setup here, ungrounded USB adapter with the lights, turning on the meter. Now I'm going to wrap the meter with this shielding cloth. You're not going to be able to see the number, but it's gonna get real quiet because the meter is no longer registering super high electric fields. If I take a really close look, yeah, looks like it's under 1 or 1.5 volts per meter. Take this out. We're back to where we were. Right? So fabric is another shielding fabric or other shielding materials like mesh is also another good option. However, this is the second part of the EMF education series, and we're also going to address how fabrics can be helpful against wireless radiation. So wireless radiation comes from, you know, everything that has wireless communication. You know, your cell phones is one of the most notorious, your computer, you know, cell towers outside your house, Wi-Fi routers, smart devices. So it's going to be coming all over, you know, from external sources and internal sources in your room, in other rooms, in other people's homes, as well as the infrastructure in your city, such as the Wi-Fi or 4G and 5G towers. So actually your microwave is also another source. When you run your microwave, they're actually using the RF radiation to heat your food. So that's another separate topic, whereas looking into the effects of what microwave radiation has on the water, the structure of the water in your food, that's likely why it also dries up your food, similar to how wireless radiation can also dry up the water in your body, right? So if you go back to cellular biology, the electron transport chain or the Krebs cycle ends up converting food into energy, which is ATP, CO2, and also water as a byproduct. And having that water sort of interfered from wireless radiation and EMFs can definitely have an impact on every cell of your body. So with that said, we use this meter to measure wireless radiation. And again, using distance to mitigate is one thing, but these are more difficult because unlike electric fields, wireless radiation has a much longer range. 4G and 5G can travel for meters, kilometers. So you might need more than, let's say, moving your bed, or especially for the external sources, you might need some shielding material for like a sleeping sanctuary. So let's do a quick demo. I'm going to turn this on. And this phone is currently on airplane mode. The phone I'm filming with is also on airplane mode. So you see that you want to look at the number on the top, which is the peak. Not too bad, right? So it's in the moderate to high. Now I'm going to turn the phone on, or rather take it off airplane mode. So you hear that noise and you see that number go up, and that's essentially what your autonomic nervous system is sensing. That pulsing, and that actually maxed out the meter at 3.18 million microwatts per square meter. Definitely harmful. So I'm going to turn the airplane mode on. We see the levels come back down. So what can we do about wireless radiation? Number one, distance, obviously. If you're sleeping next to your phone, that's probably not a good thing. If you're working next to your phone or a phone right on your body for long periods of time, that's also not a good idea. A lot of these phones and any wireless gadget often comes with a warning label regulated by the FCC that says you should not use this device within, let's say, an inch of your body. Again, using the inverse square law, putting it further away from you, that helps. Keeping it in airplane mode, right? From what we can see, it emits no wireless radiation when it's truly in airplane mode, which you have to verify with a meter. Sometimes with the iPhone, it tricks you that it's in airplane mode, but it's just having the Wi-Fi disconnected, Bluetooth disconnected, but it's still searching for a signal, which still would lead to a lot of radiation. So configuring your phones, your laptops, and verifying with a meter is also something we do with our assessments. So let's say you need to use your phone, right? Everyone needs to use their phone. In a sleeping environment, or clothing, or even in the form of curtains to protect from radiation coming from outside. This fabric, again, the same one we demonstrated for electric fields, is also very effective with wireless radiation. So I turn the phone back on, off airplane mode, and I'm going to wrap the meter. And make sure it's fully covered. And now it's very, very quiet. You no longer hear that screeching noise. Let me just make sure it's, once it comes out, right, so we're back in like the 300,000, 400,000, back in the millions. So let me try one more time. Hopefully this time you can see the LED go down once I wrap the meter. Right, so all of a sudden it jumped down into the yellow and the green zone. And now it's definitely in the green. You cannot really see that. Yeah, so typically one layer of this will be good enough. This one, the phone is like right next to it. So there's still some leaching in. You put the phone further away, it's going to kill out almost all the wireless radiation. So there, you can see it finally goes to the green. So having this sort of fabric installed as curtains, canopy, clothing, even bed sheets, or another good solution is window film. So we have specialized window film that blocks against the radiation. Paint is also quite effective. So it'll be a black layer of paint, and you wait until it dries, you paint another coat of the shielding paint, and then you put whatever color you want on top as the finishing layer. Or you can also put wallpaper. So to get like a full room shielding, you know, you would use a combination of fabric, film, paint, or if you just wanted to shield your bed, you know, you can invest in a canopy, which is something you should really think about, because, you know, cell phone towers are only going to get more and more pervasive, and think about investing in a canopy that gives you, basically it's a one-time investment that gives you free healing for every night for 8 hours, right? You just need to step into your canopy to get that rest and digest, restoration, relaxation, and hopefully a good night's rest. So that's it for part 2 of the EMF training series. Again, the wireless radiation also has different frequencies, and there's going to be different sound signatures for each type of frequency. You know, Bluetooth gives a certain signature, cell towers also a different signature, Wi-Fi also a different signature. So knowing where your sources are coming from, where they are in the house or in the area, and how to, you know, even moving your bed away from the Wi-Fi router, or putting your phone in another room, or, you know, let's say on a shelf that's not directly near you, putting it on airplane mode, shielding materials. All these things go a really long way to mitigate the risk of wireless radiation, also known as radio frequency. Thank you. All right, welcome to part 3 of the EMF training series. This one is on magnetic fields. So this meter, the one we use to measure electric fields, also has a magnetic field setting. A little different from the electric fields, where you have it when your appliance isn't even running for electric fields. You have it live in your socket. You have it, if it's plugged in, you have it live in the appliance itself. You fix it by grounding it, by adding distance, or shielding against it. Magnetic fields is different. Electric fields come from the existence of electricity. Magnetic fields come from the flow of electricity. Meaning that if your appliance is powered off, it's likely that it's not going to contribute to magnetic fields. Whereas electric fields, doesn't really matter if your appliance is on or off, it's going to generate electric fields, especially when it's not grounded. So a really good illustration of this, you know, magnetic fields can come from various different sources, but usually think of things that have motors built into them, you know, fans, very notorious for magnetic fields, air purifiers, humidifiers, and actually just also wiring in your walls. So the wiring in your walls, when there is current flow, emits magnetic fields into the room. Magnetic fields usually decrease quite significantly with a bit of distance, so the inverse square law, similar to electric fields. You can mitigate against them by turning them off. So if the fan was high, you turn the fan off, magnetic fields go away, because there's now only electric fields, which is existence of electricity, but magnetic fields, you need the device to be on. So of course, shutting them off. If it's coming from your walls, you might need to turn off the circuit breaker so that it shuts off the power to the outlet. But that's usually unnecessary. Sometimes though, you might have some wiring errors by an electrician where, you know, things might be working as you think is intended, where you're getting power, things work as they should when you plug them in, and it's your fan's working, your outlets are working, your air conditioner is working. But a wiring error can occur where there's some mistake in the wiring of the outlet or the appliance itself that can cause very high magnetic fields into the room. And mentioning about the air conditioner, that's also another source of magnetic fields to watch out for, especially the pipes running up to the air conditioner. Not always, but best to verify with a meter. So let's demonstrate that. I have this meter on the magnetic field setting. You want to see this number, probably, I like it less than 1 at worst. 0.6 is ideal for daytime, and 0.3 is ideal for nighttime. So I'm going to put this meter on the fan. So not too bad, right? We're about 0.7. If we turn this fan on, now you see it's gone up significantly to almost 50 milligauss. Move it away, it drops quite easily. Get closer and closer to it, it goes back up. Right. So there's some good news and bad news when it comes to magnetic fields. The good news is, as you saw, it drops with distance. So you place this fan far away from where you sit, it usually solves the problem. Not always. I've seen some very high-end and very popular air purifiers where even a meter, 2 meters, 3 meters away, you're still getting a significant amount of magnetic fields radiating to that space. So it's best to verify, it's best to assess. And so that's typically the good news. It drops with distance. The other good news, as I mentioned, is it pretty much goes away once you turn the appliance off. So anything you don't need around the house, leaving them off will give you a lot of relief from magnetic fields. Whereas electric fields, you need to unplug them altogether or ground them. On the bad news, I think it comes to the shielding of it or the mitigation of it. So distance is the best way to shield. Distance from the source or not using it altogether, turning it off. But when it comes to shielding materials, you know, fabrics are not going to be effective. We have some special aluminum materials that can help with magnetic field shielding, but all in all, it's not going to be as effective as shielding wireless radiation using free fabrics, shielding from electric fields using fabric or film or paint. You know, shielding from magnetic fields is something, it's very difficult to guarantee the results. And whereas we saw like a very significant improvement using the fabric with wireless radiation and electric fields, magnetic fields, usually if it's a wiring error, just fix the wiring error. If it's, you know, coming from things you use from day to day, just put it far away. And in our assessments, we verify with a meter that, you know, let's say your head height, torso height, and feet height of where you sit for, let's say, 3 hours, 4 hours, or sleep for 8 hours per day, that you're in a safe level. And that's pretty much it for the magnetic fields. Choosing an appliance that has lower magnetic fields to begin with also helps. You know, we can do a head-to-head comparison of 2, let's say, fans or 2 air purifiers that may be as effective as removing, you know, PM 2.5, dust mites, mold, VOCs from the air, but one might generate significantly less EMFs, right? Whether that's, you know, because it doesn't have smart tech built into it, so no wireless radiation, or it can be turned off, which we can verify with the wireless radiation meter, or it has a grounding plug, so very low electric fields, or it you know, when it comes to magnetic fields, you just need to test. There's no way to know without testing which one has a lower magnetic field reading. So that's it for part 3 of the EMF training series on magnetic fields. Last one will be on dirty electricity. And one last thing I want to demo is what I mentioned as one of the shielding materials for magnetic fields. So here it's not very stable, but you can see that we have magnetic fields in the area of around 0.93 milligauss. And this shielding material, once I place it between the source, which is in the wall, drops down to 0.6. Take it out, it goes back up to 0.8. So it's not super convenient and effective as, you know, blocking wireless radiation, electric fields using like very light fabric, and also effectiveness is very high. Magnetic fields is a bit more challenging, right? This is a very thick material, and it's taking out a significant chunk, but not as much as you would see with how you could shield from wireless radiation and electric fields using fabric. But it's still helpful to have. You can use multiple layers of this and hopefully get yourself to a safe level if, let's say, distance and then turning off the wiring, turning off the appliances is not an option. Thanks. Welcome to part 4, the last part of the EMF training series. This one is on dirty electricity. So in a nutshell, what dirty electricity is, again, it's one of the 4 main types of EMFs that has biological harm on the human and the animal body. Is essentially what I can describe it as dissonance. Dissonance in the power that is pulled in from the grid into your house and onto your wiring of your home. And typically what happens is, for Thailand, for instance, we operate at 230 volts, 230 volts, and at 50 hertz, right? So 230 volts, 50 hertz, what we expect is a smooth sine curve. If we measure with a spectrometer, we see that sine curve happening. But dirty electricity is when we're using a bunch of different appliances in the house. You know, the lighting in the house can also contribute, you know, so LED or fluorescent lighting is notorious for disturbing that perfect sine wave. And once you plug all these things in, it creates dissonance and it bleeds into the house as a form of EMF radiation. So dirty electricity can be measured with a DE, or dirty electricity meter. We kind of want that number less than 100 millivolts. And when we do assessments, we test this in almost every outlet of every room. And we try to bring that number down under 100, either by eliminating the sources, you know, like the LED lightings that are causing the high dirty electricity. Inverters are another notorious source. Things like your solar panels, or, you know, your car EV chargers, things that it has to convert AC to DC electricity, is also another big culprit when it comes to high dirty electricity in the house. So let's measure the D in this room. You see that we're currently at about 320 millivolts. And like I mentioned, we want this under 100 or even under 50. So apart from, you know, reducing the usage of appliances that drive dirty electricity, using dirty electricity filters is also another very quick fix and very effective one. So this is an example of a dirty electricity filter. It doesn't have any other function aside from removing or reducing dirty electricity. And you're going to have some spare outlets in the house. It can also go into the extension cords if you run out of outlets in your house. And let's see the before and after once you plug this in. So again, we started off at 340, 350. I'm gonna plug this in. all of a sudden we're down to 160, 170, right? And if I plugged another one in, it's going to go down to under 100, maybe even under 50. So that's a very quick fix. Just plugging these around the house. You know, you might need 2 of these per room, 2 to 3. And the good thing is that they're very portable, so you don't want to invest in a ton of these. You can carry 2, put them in the room that you're staying in. Let's say you're working 8 hours in the office, you plug it in, you move to your bedroom, you take them with you and you plug them in the bedroom, right? And essentially it reduces that dissonance and restores the sine wave that is the ideal situation for the house. And another thing to concern with dirty electricity filters is that they do generate magnetic fields, which we covered in the earlier section of our training series. It decreases quite quickly with distance, so you know, basically don't plug this in right where you're going to sleep, right? So your pillow is here and you plug this in here. That's not going to be a good idea, because even though you're reducing dirty electricity, you're generating magnetic fields onto your space. So just give it like, you know, usually 50 centimeters or more, and you should be good from these filters. Again, best to verify with a dirty electricity meter and a magnetic field meter. And that's it for the last part of the training series. I think one last thing I wanted to mention, since I do have my LAN cable here, which is to touch upon the wireless radiation, right? Another way to mitigate wireless radiation is to change to hardwired connections. So whether it's your, you know, wireless mouse, wireless keyboard, wireless speakers, if you change everything to wired, a wired mouse, wired keyboard, you never go back, right? It's way more it's way more reliable. You know, there's very little lag from your mouse and your keyboard. You never have to charge it again, and also you don't have to worry about the EMF radiation. And make sure you also turn off the Bluetooth and all the wireless settings of your device once you plug those in. Same for internet. You know, if you can go old school and use Ethernet cable, which I have here. You know, you can plug this into your TV, your Apple TV, your gaming console, your computer, any device with a Ethernet port. If your device, let's say an iPhone, doesn't have an Ethernet port, or your Android, you can use a Ethernet to USB-C or Lightning adapter. So this is a Ethernet to Lightning. You can plug into your older iPhones and iPads, and Ethernet to USB-C, which you can plug into your computers and newer iPhones and Androids. And you can enjoy much more reliable and much faster internet connection without the harms of wireless radiation. Again, you can still have Wi-Fi in the house, you know, for certain areas. You know, turn it off when you go to bed would be a good idea. Putting it a bit further away from you would be a good idea. But if you're constantly using Wi-Fi, which is also radiating from your computer that your hands are actively typing on, or your phone that you're holding, it might be wise to switch to a wired connection, which essentially, it might not reduce the Wi-Fi from your neighbor or your, you know, if you're still using Wi-Fi in your house, but it significantly reduces your exposure from the Wi-Fi of the gadgets that you're using, which is probably the most important thing. Start with the things that are in the closest proximity to you and fix that. You're going to see massive improvements in the EMF readings and also very likely your health and well-being. And another advantage of going hardwired is security, right? This is almost impossible to hack into. So in terms of cybersecurity, Wi-Fi can always be accessed by your neighbors if they, for some reason, get access to your password. Having wired connection, it makes that almost impossible. And speaking of security and convenience, one of our newest technologies is Li-Fi. So Li-Fi is essentially serves the same purpose as wired connection or Wi-Fi, but it's using light fidelity, right, instead of wireless fidelity. And how it works is it's able to provide you with wireless connection to your phones, your computers, without harmful EMF radiation, and it's using that by transmitting light signal. So this is the receiver. Essentially, your setup will involve plugging the Wi-Fi modem into your existing router or wherever you have connection, like an access point, so that you get internet connection to this modem. And then this modem then will transmit light in the form of infrared light, and that light will be picked up by this receiver. This receiver can be plugged into your computer, your phone, and you can enjoy wireless connection at high speeds without harmful wireless radiation. So this is quite a new technology that we're implementing. And it also has the same security benefits because anyone outside the room who does not have access to the light can also are also not able to gain access to your internet. So this is the light transmitter itself. It's using infrared light, so you can still, let's say, use it at night and not have any disturbances in terms of visible light. The setup is quite simple. You plug this in again to your access point to get wireless, to get internet connection to your modem. You have, I think, 8, or rather you have 6 ports where you can connect a transmitter. Right, so let's say you connect from the port 1 to the first transmitter, and this is like a ceiling holder, so you can also implement this right onto your ceiling, so it's flushed and it looks very streamlined. And what that enables is that it's basically giving you wireless signal to any device hooked up to this receiver. So this goes to the ceiling or some mounts that you can DIY. You can even just place it wherever you need the internet connection and connect it, hooked up to this modem, which is hooked up to an access point. This receiver, you can go wherever you want with it as long as it's still getting some sort of light bouncing off of the transmitter. And you're gonna get fast, reliable internet connection, 0 EMFs, no wireless radiation, and also extremely secure as well. So those are some more options, you know, hardwiring Ethernet, which is the old school method, and a rather more new method is using light fidelity called Wi-Fi. Thank you.